Thank you. Appreciate that. It's nasty. I know. I'm sorry. All right, so let's do completing the square.
Get out of here. God.
This is so much fun. You guys, I'm going to give you 2 days to do the worksheets. So, you're going to have to behave yourselves tomorrow because neither one of us are going to be here. All right, you ready? So, we have 2 ways to solve quadratic equations so far, right? We solve by factoring, and then we solve by finding the square roots. Okay. Now we're going to do it where we're going to solve quadratic equations by what's called completing the square. Okay, now there is a process to this, and this does get a little difficult. Here's the process. And the first thing you really have to make sure here, here's the process. Yeah, it looks wonderful, doesn't it? It's so much fun. All right, the first step, kind of like when you guys are factoring, make sure that the coefficient of x squared is 1. Oh, this is a tiny screen. You guys need a bigger screen. Let me see if I can make it bigger. There you go. All right, so the first step here, make sure that the coefficient of x squared is 1. Now, I used to teach all this individually, like put it in the form of ax squared plus b. I used to do it that way, but students would just get really confused when we went to a full equation instead of doing it in parts. So I kind of don't do that anymore, and I start by just showing you examples of this because it's really all the detailed stuff really I found kind of confuses the students, and they'd rather just, hey, why don't we just go to the equation and do it? So I'm going to try doing that. Okay, so what we're going to do is make sure that the coefficient of x squared is 1. Then we're going to write the equation in the form of x squared plus bx. Add blanks to each side. Okay, so what we're going to do is, if it has a c here, in number 1, it's got a plus c. Usually we have, a full trinomial. This is just ax in the form of ax squared, if you remember. It's in standard form. Y equals ax squared plus bx plus c, right? Well, what we're going to do is we want to get the first 2 terms by itself first. Okay, so if I look at number 4, I'm going to skip this for now. If I look at number 4, I want to get the ax squared plus the bx by itself. So the way I do that is to add 3 to both sides, right? Okay. So I get my x squared, and again, it's a coefficient of 1, so I can do this by completing the square, plus 10x, and while I cancel this, I get my equals 3, I am going to add a number back into my polynomial, okay? So to do that, I'm going to add back a number. So I'm going to add a blank. But remember, whatever I do to one side of the equation, I do to the other. So there's my blank. Now, we're going to go ahead and add, and this is the formula, and that's step 3. I'm going to take my b, which in this case is 10, I'm going to take 10, divide it by 2, and square it to each side. That's what I'm going to put in the blank. Okay, well, I'm going to go ahead and figure this out. 10 divided by 2 is 5. Going to square that, and I get 25. So that's the number. Oh, I'm sorry, I got it all the way on the bottom. So that's the number I'm going to put in the blanks. 25. 25. Now you're asking me, well, why on earth would we do all this? It's because we add back a perfect square every time. Every time we square a number, even if it's a fraction, every time we square it, it becomes a perfect square, right? Any number that we square is a perfect square. So this whole polynomial that I just created, x squared plus 10x plus 25, is what we call a perfect squared trinomial. And it factors, it's always going to factor into a squared binomial. So what it is when you go to factor this, you don't even have to like do the whole, arches and inner arch and outer arch. We know that, hey, we have an x times x is x squared, right? We added a perfect square, so that's going to be a 5. Okay, square root of 25 is 5. That's a perfect square. And this sign is a plus, so we're going to have a plus. That side's factored. Do you see how I got that? And this may take a couple of problems, obviously, to get used to. And then I'm going to add 3 plus 28. 3 plus 25 is 28. Remember how we solve these? We can do it by radicals, right? Just like we did on this section. Finding the square roots. Now it's in that finding the square roots form. So now we solve, and the whole idea, obviously, is to solve for x, right? So now I take the square root of both sides. Square root cancels out the power of 2. I can drop my parentheses now. I get x plus 5 equals plus or minus square root of 28. We have to get x by itself, right? So we're going to go ahead and subtract 5 from both sides. And I get, these cancel out, I get my x equals, now remember, don't combine these, negative 5 plus or minus. Now, can we simplify the square root of 28? You remember how I taught you to do that? Take 28, divide by 2, it gives me 14. The highest perfect square under 14, let's see, 16 be 9. Well, 9 is not a factor of 28. Let's see, what would be the next one? 9, 4. 4 is a factor of 28. It's 4 times 7, right? So I have plus or minus. I could take the square root of 4, which is 2. And then what I have left over is the square root of 7. So we're putting an awful lot of concepts together to get our final answer here. Everything that we did in the past couple weeks, guess what? It all comes together here. And when we do, by the end of the week, when we do complex numbers, We're going to need everything that we learned. Okay? Even when we do the quadratic formula Wednesday. All right, so let's do a couple more. It's going to take a while to get the hang of this. It's not something that, you know, it's going to take a lot of practice. It's not going to happen one or two problems. Okay, first step one. Make sure that I have a coefficient of 1, which I do. Step 2, write the equation in ax squared plus bx form, which means I want to cut it off here. So I'm going to add 35 to both sides. Okay, so I have my x squared minus 2x. Now I'm going to cancel these, so I'm going to add a number back into it, a perfect square, equals, I have my 35 here, and then I have to add this number to this side. That perfect square I got to add to both sides. Now I find my perfect square. What I do is I take my b here. Now you can include the negative sign if you want, but remember, we're going to square it, so even if you take a negative, it's going to come out positive. Okay, so I'm going to take my b. Now, again, you can take the negative sign. I'm not going to because, well, sure, why not? I will. Divide by 2. I'm going to square it. So I get, let's see, negative 2 divided by 2 is negative 1 squared, which equals 1. That's my perfect square that I'm going to add back to my original polynomial. So here's 1. Here's 1. This becomes a perfect squared trinomial, so its factor is going to be a perfect squared binomial. It's my perfect squared trinomial, so its factor is going to be a perfect square. Okay. X. Now this is a minus this time, so I'm going to need a minus 1. The square root of 1 is 1. Equals 35 plus 1, 36. Square root both sides to get rid of the power of 2. So I get x minus 1 equals, x minus 1 equals plus or minus square root of 36. Now this is a perfect square at 36, right? So actually that equals plus or minus square root of 36 is 6. Okay, so I'm changing this to plus or minus 6. So I'm going to add 1 to both sides to get x by itself. So x is going to equal, now these are like terms. So I have positive 1 plus 6 is 7. Positive 1 minus 6 is negative 5. These problems are long. There's no easy way to do these. You're going to have to follow each step by step. There's no shortcuts. There's no easy way to learn this other than practicing. There are some patterns, though. Yeah, Eddie.
You divide it by 2 every time?
Yes.
Okay.
That's the formula. Divide by 2.
Okay.
Okay? Now, let's see if we can pick up a couple of patterns. Okay? All right, number 5. We already have the x squared and the x term by itself. So all we have to do is add a perfect square to both sides. We don't have to subtract the number out or add a number first. So I have my x squared minus 6x. I'm going to add a perfect square, and then I have to add that perfect square to this side. Now you should start recognizing some patterns here on the next step. Half a 6 is 3. 3 squared is 9. You should be able to do that in your heads almost, right? But, we'll keep doing it. I'll keep writing it out because you have to know what's going on. So I'm going to take my b, which is negative 6, divide it by 2, square it, which equals negative 3 squared, which equals 9. So I'm going to add 9 to both sides. That gives me my perfect squared trinomial, which is going to factor to a perfect squared binomial. I get my x. Here's my base, minus 3 squared. So that's kind of a pattern right there. If you write out this step, that goes right there. Equals 8 plus 9. Oh, I forgot my 8 here. Equals 17. So you could almost go from this step to this step. When you do enough of these, this actually kind of just happens in your head after a while. Take the square root of both sides. Cancels out the power 2. I get x minus 3 equals plus or minus the square root of 17. Add 3 to both sides. And my answer is x equals, now 17 you can't simplify, it's a prime number. So I have 3, don't add those, plus or minus the square root of 17. Yeah.
Where did the negative 6 over 2 squared out? Where did that go?
Negative 6 divided by 2 is negative 3. Then I have to square it. Negative 3 squared is 9. Okay. All right. Let's do another one. Yep. Okay, I have to make this 2 terms. I need an x squared. I need my x squared. I need my 5x. Then I have to find a perfect square to add to it, as well as get rid of that 1. So 0 plus 1 is 1. Then whatever I add to this one, this side, I have to add to this side, the perfect square. Anybody know what the number is going to be for the perfect square? 2.5 squared, right? 5 divided by 2 squared equals 2.5 squared, which I can't do in my head. I'm way too sick and don't even feel like it. What is it?
6.25.
One more time.
6.25.
6.25. So I'm going to add 6.25 to both sides, or 6 1/4, right? Now you're thinking to yourself, oh my God, this is fractions, decimals, but remember our little shortcut, right? This is going to be a perfect squared binomial where I have x and my base is positive 2.5, or use that plus sign, equals 6.25 plus 1 is 7.25. Don't forget that plus 1. I do that all the time. Take the square root, both sides. Cancels out the power 2. I get x plus 2.5 equals plus or minus square root of 7.25. Subtract 2.5 from each side. I know I can't simplify the square root of 7.25. So x is going to equal negative 2.5 plus or minus square root of 7.25. Okay. All right. You're probably asking yourselves, well, hey, what if the coefficient of x squared isn't 1? Guess what you get to do? You get to make it 1. All right. What we're going to do here is we're going to see if that coefficient of the x squared is a common factor or a common term throughout the polynomial. Number 8, it happens to be, I can factor out that 3, where I have x squared minus 2x, sorry, I'm dividing out a 3, minus 4 equals 0, and guess what happens to the 3? We divide both sides by 3, and it kind of, I don't want to say goes away, but it goes away. Okay. All right, then you just start the whole process over again. Add 4 to both sides. So I get x squared minus 2x. I'm going to find a perfect square to add to it. Equals 4. I'm going to add the same perfect square. Negative 2 divided by 2 squared is negative 1 squared, which is 1. So now it becomes x. Oh, sorry. And then I have my minus 1 base, right? Minus 1 base squared. 4 plus 1, 5. Okay, I'm going to move this back up here. X minus 1 squared equal 5. Have to get rid of that power 2. Take the square root of both sides. So I get my x minus 1 equals plus or minus square root of 5 then I'm going to add the 1 to both sides. So x equals, unlike terms, don't combine them. Number goes first, then my simplified radical of square root of 5 follows. All right, the last thing here is, if you notice, this whole x minus 1 squared equals 5, that's almost like vertex form, isn't it? Vertex form is y equals a times x minus h squared plus k. That's our k. Here's our x minus h squared. So we're almost there, so why not put it in vertex form? Okay. So we're going to keep our y there instead of 0. We have y. So we'll follow our procedures, our process here, right? I'm going to get my two terms by itself, so I'm going to subtract 11 from both sides. So I have y minus 11, because these are unlike terms, equals, well, actually, I'm going to find a perfect square to add to both sides, right? Equals my x squared minus 8x, and then I'm going to add to it that perfect square. To find the perfect square, I need to take half my b, then take my negative 8, divide it by 2, square it. So I have negative 4 squared, which equals 16. You with me? So now I do have two terms to combine here. I have y minus 11 plus 16 is y plus 5. I should have put this lower. Y plus 5. My perfect squared factor here is going to be x. Here's my base minus 4 squared. Now all I have to do is get that k to the other side. Back over to the other side. So minus 5, minus 5, and here's my vertex form. Y equals my x minus h, x minus 4 squared minus my k, minus 5. Let's do one more of those. Okay, I have to get my x squared and 14x by itself, so I'm going to add 3 to both sides. So I have y plus 3. And this time I'm not going to forget, I have to add a perfect square to them. my x squared plus my 14x. And then I got to find a perfect square to add to that side, the same one. I'm going to take 14 divided by 2, square it. So I get 7 squared, which is 49. There's my perfect square. Okay, y 3 plus 49 is 52. I have my perfect square binomial, which is x plus 7 squared, and then subtract 52 from both sides. So my vertex form for this standard form, quadratic, is x plus 7 squared minus 52. Piece of cake, right? It's going to take some practice. I'm going to post this video so that you guys can go back tomorrow, and if you're having trouble doing the worksheets in class, you can go back and watch the video, and it should be able to, you're going to have to work on it. It's not, like I said, it's not something that's going to happen overnight. Any questions, guys?